Okay. Good afternoon, class. This is chemistry. Okay, this time for chemistry class. And I'll be taking you. My name is Elizabeth. So, from last week class, we talked about oxidation and reduction reaction and everything you need to know about the reaction. But because of time, we couldn't attempt any past questions. So today we'll be attempting some questions. And so for the first 15 minutes, so by 2:20, we should stop and then move to the lecture of today. The class of today will be around acid, base, and salt. Okay. So the first question for today is year 2023, question 28. 2023, question 28. The oxidation number of Mn in the radical MnO4 minus is options A +1, B +3, C +6, D +7. Oxidation number of Mn in MnO4 minus. Last class I spoke about oxidation number, whose guiding assigning of oxidation number, and we know from last class that this is a polyatomic ion. And so to calculate the oxidation number of Mn, we assign it to be X plus 4 of oxygen, 4 into bracket. Oxygen in this state is -2. And the charge for this compound is -1 because it has a charge. And so this is X minus 8 equals to -1. X equals to -1 plus 8. X equals to +7. And that tallies with option D. So let's attempt another question. 2020 question 8. 2020 question 8. What are the possible oxidation numbers of an element if its atomic number is 17? Option A, -1 and 7. B, -1 and 6. C, -3 and 5. D, -2 and 6. The question again. What are the possible oxidation numbers for an element if its atomic number is 17? So the atomic number is 17, right? When looking at it, once atomic number is 17, it falls between the first 20 elements, right? And 17 is chlorine, but let's do it. The first shell will take 2, the next 8, the last 7. Don't forget, octet configuration is 8. And so that means this shell, which would be 1, 2, 3, 4, 5, 6, and then 7. So 1, 2, 3, 4, 5, 6, 7. It needs 1 more electron to gain stability, right? And so if it gains 1 more electron, it is -1. And at this state, it is 7. So the possible would be -1 and 7. That tallies with option A. Electronic configuration would be -1 and 7. Let's move on to 2018 question 9. 2018 question 9. What is the oxidation number of nitrogen in Al? Let me write that on the board. Oxidation number of nitrogen. Nitrogen in Al NO3. Oxidation number of nitrogen. Option A, +1. Option B, excuse me, +3. Option C, +5. Option D, +6. Oxidation number of nitrogen in this compound. We know this compound is a neutral compound. So the net oxidation number for this compound is 0. Aluminium being in group 13 will be +3, +3 into brackets. We don't know nitrogen, X, plus we have 3 atoms of oxygen. So 3 into bracket minus 2 close bracket equals to 0 since it is a neutral compound. So this is 3 plus 3 into bracket x minus 6 equals to 0. 3 plus 3x minus 18 equals to 0. 3 minus 18 minus 15 equals to 0. 3x equals to plus 15. Divide both sides by 3. X equals to plus 5. And that is option C. So let's move on. 2015 question 48. 2015 question 48. 2015 question 48. All right. 2015 question 48. MnO2 plus 4HCl. Products are MnCl plus Cl2 plus 2H2O. That's the reaction. So in the reaction above, MnO2 acts as MnO2 acts as a catalytic agent, B an oxidizing agent, C a bleaching agent, D a reducing agent. These are equation of reaction. MnO2 plus HCl giving MnCl plus Cl2 plus 2 moles of water. MnO2 acts as, in this reaction, MnO2 is one of the reactants, and this is redox reaction, that's oxidation reduction reaction. This is the half equation. There is oxygen here, there is no oxygen here. So we can say it's the removal of oxygen. And removal of oxygen from last class is what reaction? Reduction. So that's reduction half equation. And MnO2 is the reactant. The reactant that undergoes reduction is called oxidizing agent. The reactant that undergoes reduction is called oxidizing agent, and that is option B. So let's move on. 2015 question 19. 2015 question 19. Okay. H2S plus Br2 moving to 2HBr plus S. In the reaction above, the oxidizing agent is A. Sorry about that. In the reaction above, the oxidizing agent is A, H2S, B, sulfur, C, Br2, D, HBr, oxidizing agent. And we know oxidizing agents will undergo reduction. So let's look for the reduction half equation, and the reactant of the reduction half equation will be an oxidizing agent. This is from here to here. And this is from here to here. Here to here is removal of hydrogen. Removal of hydrogen. Here to here is addition of hydrogen. Addition of hydrogen is what reaction? That is reduction reaction. So this is reduction. Removal of hydrogen is oxidation. Addition of hydrogen, reduction, removal, oxidation. And so we know our oxidizing agents would undergo reduction, and so this is the reduction. So what's the reactant for the reduction half equation? Br2. And so C is our answer. We've used the first 20 minutes. Let's attempt one more question. Any question? The class is done. Maybe the last one. We'll solve it and move on. So let's attempt 19. Okay, that's what I just did. 2024 question 23. Okay. So we'll attempt this and then we'll move to the topic of the day. I just said now. Question 23. H2O plus carbon to give H2 plus CO. The oxidizing agent in the reaction above is A, H2, B, CO, C, D, H2O. What do you think the answer would be? Anybody? This is the equation of reaction. The oxidizing agent in the reaction above is any opinion. We have Jose, Adun, Akolasa, Faithful, and Ralph. The answer is what? C. All right. Any contrary reduction? Any contrary opinion? The answer is A. Did you say A? I didn't get you. D. The answer is D. Okay. Any contrary opinion? The answer is now D. Okay. Any contrary opinion? Okay. So we know for oxidizing agents would undergo reduction, right? An oxidizing agent is the reactant undergoing the reduction. So let's do this. This will be from here to here. This is the half question, and this is from here to here. Here and here, the difference is oxygen, and that's removal of oxygen. Here to here, addition of oxygen. Removal of oxygen is what reaction? Reduction. Reduction. Addition of oxygen is oxidation. Oxidation. And so we want the reactant undergoing reduction, and then that reactant undergoing reduction here is H2. So D is our answer. Okay, so we'll stop here and then let's move to any question. No question, move to topic topic of today. And so that is acid, base, and salt. So acid, base, and salt. Apart from pH value, there's no calculation at all. And so I'll be doing a lot of talking. And so I would enjoy you to write. If you want to write at all, write fast so that we can cover all, because it is more like a 3 topics, acid, base, and salt under one. That's how JAMB wrote it. So on a normal day, it's meant to be 3 topics, acid separate, base separate, and then salt separate. But under the syllabus for JAMB, they're all together. And so we would try as much as possible to cover with a minute to the notes. Okay. So let's start off with acid. A minute. I want this to load. Okay, so have you wondered why some fruits are sour? Or ripe orange, lime? They kind of have this sour taste, this slappy taste. Why? It's because they all contain a particular compound known as acid. Why your lime or ripe orange, apple will give this slappy taste is because it contains the compound acid. So what exactly is acid? Acid is a substance in which in aqueous solution produces hydronium ion as its only positive ion. Acid is a substance in which in its aqueous solution, that means mixed with water, produces hydronium ion as its only positive ion. That means H2O will give H plus OH minus. This is the ion, the only positive ion. And we can classify acid based on their source, like organic and inorganic. Organic would be from plants and animals, while inorganic are from inorganic matters, that's elements. They are synthesized in the laboratory. Organic acid would be your citric acid, your malic acid, ascorbic acid, malic, citric, ascorbic acid, uric acid. Those are examples of organic acids. They are from plants and animals. Whereas inorganic acids are acids synthesized in the lab. That would be your HCl, your H2SO4, your HNO3. You will notice for this acid, you have this hydrogen. This is what's called replaceable hydrogen. So for inorganic acids, they are from inorganic matter. Classification can also be based on their concentration, where we have dilute and concentrated acid. Don't forget the definition: substance in which in aqueous solution produces hydronium ion as its only positive ion. So for dilute acid, we are considering the solution, and it will be the acid itself and water in order to form a solution. Assuming you decide to prepare 100 ml of HCl solution, that's HCl acid, and the acid itself is around 5 ml, whereas the water added is 95 ml. This acid prepared would be a dilute acid because we have more of the solvent to solute. And actually, solvent is meant to be more, but the comparison is a lot. Unlike when you have 100 cl and the acid is 90 and water is 10. Acid here is the solvent, the water is the solute. Whereas for this dilute, the acid is the solute, whereas the water is the solvent. So based on the quantity of water in the solution determines whether it is diluted or concentrated. Also, another classification will be, let me clean the board. Based on ionization in water. Here we have the weak and the strong. For the weak acid, all of the replaceable hydrogen has been replaced. Whereas, for the strong acid, all of the replaceable hydrogen, like, let me give an example. All right. I didn't get it. The dilute and the concentrated. The dilute and the concentrated. What's your question? Based on concentration. All right. So I can continue. Strong acid ionizes completely in water, whereas weak acid do not ionize completely in water. HCl can be, this would be the anion and this would be the cation and this would be the anion. All of these hydrogen have been ionized in water, whereas for weak acids, it would be CH3COO plus H plus. Not all of the hydrogen will get ionized in water, but here all of the hydrogen gets ionized in water. Basically, organic acids are weak acid because the alkyl group, the hydrogen of the alkyl group will not be ionized in water. Only the OH bond, the hydrogen of the OH bond will get ionized. Are we good on that? So now let's move on. Any question? Okay. Let's talk about physical properties. Dilute acid after sour taste. Also, concentrated acids are usually corrosive. So concentrated acids. That's why you don't add water into acid, rather you add acid into water. And so these are two physical properties. Let's talk about chemical. First would be our neutralization reaction. That's the reaction between acid and base.